Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Coding can be complicated. Analyzing code, even more complicated. Coding a static code analysis dives into the realm of metacoding. Creating code to analyze code doubles or even worse the complications. In this episode, we are talking with Yuri Minaev from the PVS-Studio team about building and maintaining a static code analyzer. But before we get started, Yuri, I did not double check that I remembered how to pronounce your name. Was that correct?
It was close enough.
Close enough. All right, good. So, Will, what have you been fighting this week?
I have gotten back to working on our new podcast website after, a month or two of not much progress. So I was working on that this morning before we got on this call, actually. So, Yuri, how about you?
Well, I'm still trying to get used to our new kind of work schedule because we have half of people go to the office 1 week and the other half stays at home. And next week we swap places. So I'm just getting used to that. Otherwise, it's basically work stuff, and I'm still recovering from my moving houses. So it's kind of a downtime, if you say so.
Yeah, that makes sense.
Yeah, I can imagine that. Moving's always rough.
So I'm going to be helping Amanda move soon enough. So yeah, I'm not going anywhere, but she's moving into a house with some friends. So
her furniture's not all oak like yours, is it?
No, it's not. I have been fighting Postman and Windows, working with file downloads. Postman doesn't send the file type to Windows, and then there's this Windows default that is set to hide the extensions, and it hides it from itself. So when you try to download a file, even though it's in the file name, Windows hides the extension and then doesn't know the file type.
This one is stupid. I don't know why they keep it on by default to hide extensions. I just don't get it. Why?
I don't either. And so I've eventually figured out the problem I was having, but Will and I were fighting with that. Like, I was fighting with it for about a day, and then I messaged him at the end of the day, and I'm like, hey, I am stuck. Can you point me to, I can't even find anything about how to fix this. So it was the next day I reached out to some of my coworkers. And I was like, hey, does anybody know about this? And right about the time that one of them replied with the solution, I figured it out. Of course, that's the way it works, right?
That's why you ask everybody first.
Yeah.
Sometimes you just explain the problem to solve it. It always works.
Yeah. So we're talking about C++ today. My first assignment for school this semester, well, it was due on Monday. I actually emailed the professor today and found out that because I was like, he hasn't posted it, and like, it's due Monday. And he's like, oh yeah, I announced in class Monday that we're gonna hold off on it. I'm like, yeah, I emailed you saying I wasn't going to be in class. And he's like, oh, I meant to write back. I'm sorry. Yeah, it's not going to be for a couple more weeks. I'll post it this weekend. I'm like, all right, cool. I mean, that's makes my life easier, but so had a good birthday week. Tech team party on my birthday. Our sound guy and I wore kilts. That was fun. Then Saturday we went axe throwing and ate at Empanada Sonata, which is pretty good. Will showed up several hours late because he got the time wrong. And so he and I hung out afterwards, which was cool. And then our children's pastor gave us all candles for Christmas. And I was talking about how much I really liked the scent. It's Whiskey and Oak by Patty Wax, a candle company here in Nashville. And so our tech team lead gave me 2 much bigger candles for my birthday. So I was like, I need to buy some because I burned it. Like, the whole big candle I got for Christmas because I'm like, I don't normally burn candles, and I loved that smell.
It's nice when you can make the place smell like a hunting trip.
Yeah, right.
Saving money is hard, especially coming out of the holidays. Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
A lot of people think they're too young, they don't have enough investments, or that it's going to be too expensive to use a financial planner. But the thing about Lucas is he has a unique pricing model that will help you no matter where you are in your financial journey.
Lucas is also a fiduciary for his clients, which means that he's not here to sell you a product, but to help guide you to a better financial situation.
So you guys can find some fun, free resources and learn a lot more at levelupfinancialplanning.com.
Static code analysis automatically examines source code before it compiles or is run. It does this by comparing the code to a set of rules or standards. This process allows for the automation of code reviews and can be used in conjunction with peer reviews.
Yuri is a C++ developer working for the PVS-Studio company as one of the developers of the code analyzer for C++. His primary responsibility is to keep low-level stuff in order and add new features to the core module. Yuri has been developing software for over 12 years, working with the PVS-Studio team for 2 years. When not coding, he periodically gives talks at various conferences, mainly on topics related to static code analysis and C++.
PVS-Studio analyzes code designed for 32-bit and 64-bit systems, as well as embedded ARM platforms. It's cross-platform, working on Windows, Linux, and macOS 64-bit environments. You can use it to generate reports that help you find and fix bugs before they become a problem.
The last time we spoke with Yuri, he discussed what a static code analyzer does and how using one like PVS-Studio can be useful in your development. In this episode, we'll be talking to him about working on a code analyzer, the frustrations, and the fun. Now, Yuri, the last time we asked you what got you started in programming. That's sort of our standard one that we ask everyone their first time on the show. This episode, we want to ask, what keeps you excited about the field?
Oh my goodness. Well, I guess it's because this is really an interesting and creative thing to do. You are not limited by basically anything except your imagination and what the client wants, but I think we don't care about that right now. But really, this field, it's interesting to me because you always learn something new, and you can create some interesting stuff basically at the basic cost of electricity. Isn't that amazing, really?
Yeah, I like that, and I like how it's constantly changing. So, like, even when you've got stuff down, you get to learn new stuff.
I've got a passenger.
Yeah, guys, Yuri just showed us his cat laying there with him. So my dogs are shut outside of the office with bark collars on so that they don't bark in the middle of the day if someone delivers a package.
My coworkers say hi to my dog because she's on my morning call, trying to climb into my lap because she hears me start talking and can't relate to I'm not talking to her. So here she is.
Yeah.
And so I have to look around the dog to see my coworkers on the screen. It's great.
I remember stepping away and I have a speaker for when I'm in a meeting or something and not recording. And so I stepped away to fuss at the dogs, figure out why they were barking. And I heard one of I think our project manager go, "Where'd BJ go?" And then the business analyst said, "He's fussing at his dogs, I'm pretty sure." And I came back, I'm like, "Yep, that's what I was doing." Because they all have dogs at work, so everyone understands.
Yeah, but I do like what you said there about it, the infinite creativity that's possible, because you can kind of turn models over in your head and you're not wasting physical goods while you're playing with it. And that's probably the most fascinating thing, which I guess is probably why you're so well suited to working at PVS, right? Because you have to play with other people's mental models with your own mental model.
Yes, and considering how old ours is, I think it's good we're not wasting anything.
So let's go ahead and jump on into some of these fun questions we have. The first question we're going to ask is, how difficult is it for new developers to start working with the code base and like get an understanding of what's going on?
Well, it's difficult. And it's really kind of the learning curve is steep because people who come to our company, usually they know the language at some degree, but they don't really know anything about how compilers work, about how to analyze syntax, what parts it consists of. So they come, like, imagine you are a car driver, a taxi driver somewhere, and you come to some other place and they lead you to a room and it's a big hangar and they say, here's your taxi now, and there's a jet there. So it's kind of a difficult skill set a little bit from just knowing the language itself. I remember when I first came to PVS, to me, it was everything new. I had experience with C++. I had my own pet projects back then, and it was, I wouldn't say shocking, but it was difficult to even understand what's going on there. Oh, I remember one interesting thing about that. I'm still laughing about it. We have a syntax tree, right, in the analyzer, and we need to traverse it periodically to get to the nodes we want to get to. And there is a function, there is a set of functions which climb the tree up to some node. And there was that function called up to something. And I'm sitting there, it's my first week, I'm sitting there debugging it, and I see if some node up to something, and I look at it and say, is that thing that smart? It can realize that the tree node is up to something sinister.
I guess that's kind of the idea, though, right?
Well, yeah. And, well, actually, most people which come to work with us, they're not really experienced, and they have hard time starting working with it even because they just typically go right out of the university. And I blame the university for that. Well, not entirely, but there is its fault here because what they teach you in the university and what you get in practice, it's kind of different stuff. Unless you do something on your own. That's how we learn like reliably.
I think it's like that for a lot of fields too, because I remember when I was in psych in grad school for psychology, like they didn't want you to have a job because they wanted you to be completely focused on psychology. But then I looked at my cohort, and out of like the ones who didn't move on to something else, but like stayed in psych, the majority of them were people who had a job because you knew what you were getting yourself into. And I think that might be similar with programming. I haven't actually looked at that from a statistics standpoint, but I would believe that the people who are doing side projects or have jobs or something where they're working in the field and understand what they're getting into when they get out of school versus just like studying and then coming out and going, oh, this doesn't like this way of programming does not work in the real world.
Yeah, that matches my experience as well because I, went to school for it, and we didn't get. Of course, this was a while back. Obviously, when I graduated in 2002, and we didn't have experience with source control.
I have a story about that. Remind me.
All right.
No source control stuff. No, like our database stuff was a lot weaker than what was absolutely necessary. Now, I had a teacher that was pretty brutal in school. And so my impression was that I was actually better prepared than a lot of graduates, and I was still not prepared. We knew all the theory and stuff. We could say this was, an O n cubed growth rate on this function, but we couldn't write a lot of the functions like we needed to. So yeah, that seems to be across the board. And I will say too, as far as some of the stuff that you're dealing with, I had a bit of a learning curve in C#, getting used to expression trees, which are, that's our way of doing abstract syntax trees. Getting my head around that took longer than it probably should have. I think Beej remembers those conversations.
Yeah, I do remember those. Yeah. So what was that about source control you were going to tell us?
Once we had one girl who came to us from, what was that? She was like undergraduate or something. And she was accepted to the company to be a C++ programmer. And, well, first, what shocked us all is that she thought that she had to draw that, what do you call it? The code algorithm diagram before you even get code in. You
like
just
a
have
flowchart
to do that. Yeah, flowchart. Because they teach you that in the university. You have to do that. Next, she wanted to learn the entire code base by heart. Just like, I just want to read it all and learn it, and before I do anything, because I'm afraid to break anything. And the thing about source control, all the changes she made in the code, she kept them in separate files, in separate copies, basically. So when I look at that, she called me to do a code review or something. I could come up to her desk and I'm looking at what's going on her hard drive, and I'm just like, well, what are you doing? Well, that's in case I break something. And I'm like, come on, you can revert it in the source control. And she goes, oh, I don't know anything about source control. I tried to read the book, but it was too big. I didn't manage. So it's kind of funny. It's kind of sad, but that's what happens sometimes. I just don't know. And just a disclaimer, I don't think that girls are worse programmers or anything like that.
Yeah, it's just a recent graduate thing. It's like they're expected to be a ball player, and they were taught the physics of throwing a ball.
Mm-hmm, mm-hmm.
And there's a gap there.
So on the source control thing, though, I've seen the same kind of attitude from much older developers.
In the bad old days, we used to just make copies of the code base periodically, and you could manually revert. And
yeah. So like I have one developer that I have worked with, and he's been around for a while, but I said something about because if I want to test something out, I'll make a local branch and I'll write my code, see if it breaks it, and then I can just totally destroy that local branch and
nobody knows.
Yeah. But he's like, yeah, I made a local branch and then I saved a copy of my code over here so that I have a backup in case something happens. I'm like, all right, dude, that's a little overkill, but that's fine. But he is not comfortable with that yet. I think with a little bit more time and seeing things, he'll get there, but he's not there yet.
Well, I think it may come from the time when Visual Source Safe was alive.
Yes, because it would corrupt everything.
Yeah.
There's some very profane things I've heard about Visual Source Safe. I worked with a guy that went to a fundamentalist Christian university, and I worked with a guy that had to deal with it. And back then I didn't know Russian at all. And I realize now when he was dealing with Source Safe, what I was actually hearing when he's muttering in Russian. Because you hear it on all the car crash videos.
I can imagine that.
Yeah. Next, we have a question about support. So how is that organized? Is it difficult to help the users who come in with problems?
Well, it's organized like it's a part of development because our developers, well, I am included in that, we deal with customer problems. And it's not too difficult because there are not many of requests usually. I I guess we like to think that it's because of the code quality, but I think it's not. I think programmers, developers who work with our tool are just, well, they can deal with many problems themselves. In this sense, it's easy because you're dealing with someone who understands what they're doing, and they can give you information you want, and they can even give you information you didn't ask for because they think it will help you. So that's the pleasant part of it. Well, the unpleasant part of it is, of course, sometimes you get something really tricky and you're just sitting there banging your head against it. especially when it comes to templates and stuff like that. When I see a lot of template code, it's just asking for trouble. I like templates. I use them all the time, but analyzing them is not a pleasant thing.
We have something similar to that in C#, with generics, and I will use those all over the place. But when you get into these weird corners sometimes where there's something slightly different and you didn't think of it when you're writing the template, you don't remember it when you're debugging it, and it hits you and you've got to mess with it for hours and hours.
Yeah, it's like regular expressions, you write one, it's clear, you understand everything, and a week later you go like, what does this thing do?
I've got a friend I can call for that because he does Perl, and the guy can look at a regular expression as long as your arm and just go, oh, I know what that does. And, oh, this doesn't handle an empty string right here. And he just, like, he's got that built-in parser in his brain. It's really, and I don't want to ever be that guy. So I call that guy when I get stuck over my head.
I just use a tool. There's some online regex parsers that you can put it in. It'll show you what's, what it accepts and what it doesn't. You can run tests against it. It's kind of nice. I don't have to do a lot of regex in my job, thankfully. But when I do, yeah, I cheat. I use a tool.
Well, I guess I have an easier time here because in C++ there is this regex library in std, and it's just awful. It's slow. It's a lot of memory, so we don't use it. So usually we just don't deal with that kind of stuff.
Does PVS-Studio do anything with regexes at all, as far as like when the client uses it?
Well, no, we don't. We don't have them in our code, and we just treat them basically as strings. We don't check them.
So it's on the client to make sure their regex is correct then.
Yeah.
Well, yeah.
That makes sense.
Yeah, because otherwise it's horrifying to think about what you'd have to do to test those.
Yeah, I mean, like it makes sense because, for example, I'm working on some software that works with our document management process, and the business analyst was telling me, well, this division is going to pass in this information here, and this. I'm like, my code doesn't care what it passes in there. Like the details don't matter. It's like, does it have the required fields? Yes, we're good to go. That's on the business to make sure they get the right information in there. So that makes sense. I can see why I understand why you wouldn't want to do that, but also it does make sense because that's more like, all right, this is on your end. So
well, funny enough, we have one diagnostic rule on HTML. Don't ask me how it got there, but when you have HTML markup in string literals, well, inside your C++ code, you can do that. We search for tags which are not closed and things like that. So we check it. It's a limited check, but we still do that a little bit.
Yeah, I can definitely see the not wanting to deal with regex, because honestly, if you're gonna optimize that, you just about have to have the data set that they're working against.
Yeah.
To tell if that regex is smart. So yeah, that would be, the more I think about it, the worse it sounds. So you guys have your own parser, or do you rely on a pre-built solution? Like, I'm not sure if you say the C-lang or Clang.
We usually say it clan, but I've heard different ways to say it, and I don't know which is the correct one. I think clan sounds better. Like, well, we have our own parser, and it was it's not our own like entirely because it's based on an open source library from a long past days. So yeah, when was it? It was about 2000 something when it died, and after that we started using it, and since then we built everything upon it. It was called OpenCX6. I don't quite remember the name because it's called differently now. Let's say that. Yeah, and that thing is it's legacy at its finest, actually. You can go there to some random place of the code and you can see ancient coding conventions when we didn't have automatic type deduction and stuff like that. And it was like I don't know how intimate you are with C++.
I had a fair bit of it in school.
I'm in school now, so I'm doing some.
Yeah, so you know that there is no such thing as a string in C++ and in C. So you have a const char pointer, and from there you're on your own. And you can see a lot of stuff there in our library, in our parser, because it's really old. We are now trying to refactor it and bring it up to the modern standards.
Because I did some Borland C++ back in college, and I remember having to do the was it LPZSTR? It's a long pointer to a zero terminated string, and then you put the name of it.
By the way, I hated that Hungarian notation, which by the way meant a different thing entirely. It was misunderstood at some point because that guy who invented it, he meant type to be not the actual type from the language standpoint, but the type of the variable in terms of what it does. So it's like a counter or something. And that's a tragic story, really.
Yeah, I actually made a comment, kind of a throwaway comment in an earlier episode, and got an email about that, and went back and forth with the guy. And he was right. I just was talking about what I'd seen it be used for, not what the intent was initially. It's kind of like waterfall. It's like waterfall was intended to not be what it became.
I would say the same with agile, but I've been some people with that statement.
Yeah, I would. Yeah, well, they're going to write you, not me.
So, Yuri, there are analyzer versions for a lot of different languages. Do they fit well together?
Well, yes and no. Mostly no. Well, because it started with C++ and it was all good and fine and dandy back then, but then C# came. So how do you do C# without throwing out everything you've got built for C++? Well, I would like to say that you don't throw it away and you find a way, but no. C# was built from scratch, basically. And then C# was used to write things like plugin for Visual Studio and a standalone utility which shows you the logs. So those are parallel universes, basically, except for that little conjunction in terms of how they fit together. And then Java came. So what do you do with Java? Well, you write a third version of the analyzer, of course, but C++ had data flow analysis by the time Java was starting. And that thing, writing it was bloody difficult. So they decided, okay, we think we can use it somehow in Java, and they did use it in Java via what is it called, GNI. So they basically took a native shared library, a DLL, and they used it in Java, and they wrapped it in some crazy wrapper code. So it may not sound too horrible, but it is, because whenever you go and fix in air quotes something in data flow, you can always break Java without intention. And well, there was a funny story about that. I think it's a funny story day to day. Okay, so one day something was fixed in data flow, and one method was made to return an optional. And optional, well, in C++, of course, it's a template, as everything in the standard library, and Java wasn't ready for that. So they've got a crash, I think, at compile time, thankfully. They got a crash. And it took them like a day to adjust their wrappers, so their wrappers could translate optional to the Java part. And they succeeded, but kind of succeeded, because it's a template. it can have any type inside it. So they had to write not one wrapper, but a collection of them for different types.
Yep. I've seen similar things wrapping Delphi code with C#.
Oh.
And I was on both ends of that. It was, where you're in the Delphi IDE and you're cussing at the way C# handles things, and then you're back in C# and you're cussing about Delphi. Then you got them both open, and then you're just cussing at the fact that it's all on your desk. You guys did you have a code analyzer for Delphi at one point, or was that?
It was for C++ Builder, which is Delphi but for C++. I remember I started. Well, my first C++ compiler was Borland 5, and then I tried Builder, and I looked at it and thought, cool, you can do windows here and all buttons and stuff like that. And then after some time, I looked at that and decided, no, it's not even C++. It's some really ugly monster. I don't think it's a mutant. Well, yeah, the syntax there got some changes, let's say.
Yeah, I think Borland 5 is maybe what I used in college, because that came out in like 96, right? And so I would have been using that in 98, 99.
Yeah, it was the most popular one, I think, at the end of 90s, early 2000, something
That's
like
what I did in high school, which was 98, 99 year. So yeah, makes sense.
Yeah, it was kind of weird for me because I did Visual Basic in high school, among other things. And it's like you got the drag and drop IDE, and then it's like, oh yeah, let's go to the blue and white terminal.
I actually had the choice. They switched from QBasic and Turbo Pascal to teaching. Yeah. I took both of those. Then my senior year, they switched to C++ and Visual Basic. And all of us got to choose which one we wanted to take because we'd had the other two classes. And so we all chose C++ because we thought it would be more fun. And I think some of the guys did it because that's what games were written in. So they wanted to do that. And I'm like, yeah, I don't want to do that. But, good for you guys. So speaking of C++, I mean, we're talking about the first versions we used, but it is still a definitely live and growing and changing language. How do you keep up with changes in the language?
Oh, well, usually it's like, it's okay. Oh my goodness, a new standard is coming in. So, no, really, we do it gradually without taking too much risk, because it's better usually to support one feature at a time, even if it takes you longer, than to roll out the entire new standard support, even if it's possible. Well, the thing we usually do when new features arrive, and that's the top priority, is not to crash on them. Like when you get new keywords or new syntax constructions, you don't want to crash on that code because that looks ugly. Well, right now I think we support a lot of modern conventions. Let's say it like that. We are not too good with template code because it's kind of difficult based on how the analyzer is built. We don't have a linker. We just have a front end. And it's kind of difficult to do, but we are moving there. I think the thing which will give us most trouble will be modules when they are accepted in the standard and when they begin to be used widely. But it's not in the near future. We are looking that way, but not doing anything. Well, to summarize it, it's not too difficult to support basic stuff like stop crashing, start understanding some rudimentary thing, but it's difficult to support new features, to make deep support for them, if it makes sense. So yeah, we are not quite a compiler, so I think if we used Clan back then or something similar, it would be easier. It was what it is.
I can imagine the legacy code is probably an issue. I mean, both with your clients using potentially old ways of doing stuff and, down in the guts of that parser. How do you deal with that while the language changes?
Well, old code we supported. So if anything, we are better on the old code than the newest code because the parts which work with the old language standards are more tested, more bug fixed, and stuff like that. So don't really have to deal with the client's legacy. But with our own legacy, that's a different story. We are trying to eliminate it gradually because you just cannot get rid of it entirely without, I don't know, working overtime for 10 years or something. But yeah, but gradually we rewrite our systems one by one and refactor them at least. And yeah, funny enough, performance increases when you do that. When you get rid of some parts of legacy code, chances are you will get a performance boost from that.
Yeah, that makes sense. That's what I'm working on right now, is replacing some of our older systems. I mean, I don't know if I'd call them legacy because they were written like 3 or 4 years ago.
It's legacy.
That's legacy for C#.
But and the thing is, they're being used for stuff they were never designed for. Like it was one of those that we built something for a specific purpose, and then management said, "Oh, hey, we've got something that kind of does this. Let's just use it for this other thing too, even though it's not really what it's designed for." And yeah, it turned into a monstrosity. And so now we're actually planning it out and building it right, which is already we're in our second sprint on this, and the stuff I've already got done, I'm like, wow, this is so much more cleaner and easier to use and understand, because it's a internal processing. So only our developers are going to use it, but they're going to be so happy about it when we get this done.
Speaking of only your developers using it, how do you even test a tool like this internally? I mean, I guess you would have to have source files that have particular problems and then run them through the thing. How does that?
Okay, so let's count that. Number one, we have a lot of code snippets which we run in tests. We have a collection of test files for every diagnostic rules, and it has examples on where it should work, where it shouldn't, where it should kind of work but shut up, or it should not shut up but fire with a lower priority. So we have those. There's a lot of them, and mostly they are synthetic code, but not entirely. Some of them are taken from, support requests from users when some false positives occur. Okay, that's one thing. The other thing is we work with different compilers and on different systems. So this pandemonium needs to be also maintained. So we have tests which test those things and make sure they work. So parsing command lines and stuff like that, pre-processing. Next, we have files from all includes from different versions of the standard library. So just get all the headers from the standard library for Windows, for Linux, for Mac, and you just shove them into one C++ file. You pre-process that, and you run your daily tests on that. That is to make sure we don't crash horribly on the standard library code, because that would be awkward.
I guess that would, man. I mean, have you ever thought about, or do you pull in, any of the open source code bases?
Yes, I was getting to that. So next thing, we've got so-called self-testers for the three systems we support, and that's those are special programs which have inside them a collection of open source projects, which they get from GitHub and whatever, and they run analysis on every one of those projects one by one. Well, actually, it's not by one because it's multi-threaded, but let's say one by one. And what they do is they keep the results from previous runs, and every new run, they compare the new results with the existing results. And this allows us to catch different, inconsistencies in how different diagnostic rules work. And that's really important because that's live code. It's taken from open source projects. It's not something we came up with or anything like that. So it helps a lot. You won't believe how many crashes we got on development stage because of that thing.
Yeah. I would believe it, actually. Yeah.
Because whatever you can imagine and think of as your test example, people will make it better in real world projects. And what else? Oh, yes, documentation. We write documentation for diagnostics, and it shows, okay, so this is a piece of code where this diagnostic rule will tell you you've done good. And this one is where it won't tell you anything. And those also should work. So those examples from documentation, they're kept in one Visual Studio solution, and we also check them every time a new diagnostic rule rolls out. Well, basically, we check them every nightly build, but you add your examples there, and you make sure everything is correct, and you then approve the new baseline log from the analyzer on that file. And when anything in any one of those places works not as intended, usually our team lead starts shouting a lot.
I can imagine that's fun. Have you ever pointed it at your own code base or at itself?
Yeah, and we do that actually every night also. And we have this utility. It's called blame notifier. So what it does, it looks at it checks your code, it checks out it from the source control, checks your code, and then if it finds errors in some lines, new warnings, it looks who did this, whose code that was, and it sends emails to everyone basically. Look, here is the new warning, which is not supposed to be there. Well,
sounds like you've gotten that a couple of times.
Well, a couple of 1,000 times maybe. I don't
know. Yeah, I can see that. We had a person that did that at previous gig and would send an email out to the whole team. So and so screwed up. They got a memory leak. It's like, I don't really think that's the most positive way to handle that, but it's nice to have a tool.
Yeah, because your way of handling that is to throw erasers at them.
I only did that to you. I don't do that in a proper work environment most of the time. Yeah, Beej, he's still, if he's over here, he won't write on that board, because I used to, like, when I was kind of trying to get him ready to get a job, he would make a mistake and I'd throw an eraser at the back of his head and be like, pick that up and erase that memory leak that you just wrote.
Multiple times.
Yeah. The thing is when he goes to an interview, he's fine because nobody's going to be that much of a jerk. He's prepared. That's psychological testing. I did it for you.
Sure. Keep telling yourself that.
Man, that sounds like I guess that's really the only way you can test it, though. You almost have to have a population of code to test against and just...
Yeah, that's pretty much the only way. Because that thing with open source projects is especially valuable, because a lot of times our usual, tests on short examples, they just don't catch any issues. They just show green, everything's good, all nice, and then you fire that thing up and it tells you a lot of trouble, like, that's wrong here, it's wrong here, there's an additional warning here, it crashed here, especially if you're not careful when writing code. And another funny story, we have a stack trace functionality now. So it used to be just, it crashes and it tells you, okay, I crashed, contact our support team. And now it coughs up a stack trace from that actual error. And one of our guys who was working on that stack trace functionality, of course, he needed to test that. So what he did, he put a volatile int pointer equal to null pointer and dereferenced it to get a segfault. So he tested that, and he did it in our live production code, of course. Well, before committing in for test purposes only. So yeah, he made sure that the stack trace worked. Indeed, he was getting that segfault and everything was fine. So he was so excited and so happy about that he committed his changes to the working repository, and well, it went south real fast. Because it was a volatile pointer, so the compiler looked at it and said, well, I'm not touching it. I know it's not used anywhere. I know it's assigned null pointer, but maybe something changes it. It's volatile. I'm not optimizing it way. So it went to the release version, and our tests crashed with a loud noise that night.
Well, at least you caught it. I mean, if that'd gotten out in the wild, that's...
Well, it was easy to catch.
Yeah.
Because it was...
You look for all the smoke.
Yeah. It was an unconditional code, a piece of code, so it was destined to destroy everything.
That reminds me of we did right after I'd started working at my job, I was a junior developer working with our lead UI developer, and we were on a death march for a month. And we got to we got into this who could make the other one laugh out loud with their error messages. in JavaScript, so like the console error messages, and like it started off with lines from 2001: A Space Odyssey, like "I'm sorry, Dave, I can't do that," and like got to the point where our BA and QA, like it got past us, we forgot to take those out, and so like our BA was showing this to to the customer, and she had the console up on there, and it was like, "I'm sorry, Dave, I'm a potato." In front of all the customers. Like, oh man. Like we're sitting in the back of the room, and I just looked over at him like, I don't remember which one of us wrote that, but we're both in trouble.
I've seen worse. Done worse. Can't tell it here though.
Yeah.
There was some ASCII art. Wildly inappropriate ASCII art.
I totally bet. Yeah. So we've talked a bit about the building of a code analyzer. Let's talk just briefly towards the end of the episode here about the usage of it. How do you effectively use static code analysis tools in a large team without slowing down the process and the deliverables?
Well, you basically use a CI system and you deploy it there, and you run it every night. Because if anything breaks, if there are any warnings on your code, you want to catch them as early as possible. And also, what you can do is, I don't honestly think that a lot of people will do that, even if threatened with, public shame for as well, my experience shows, because those emails we all get, we are still getting them time after time. But can install it on every developer's machine and make it like a post-build action, for example, to like you build it locally and you get a report with warnings right there. So this also kind of works, but sometimes it kind of doesn't. So a CI system globally on the entire team, I think it will work better, especially if you are using like pull requests in your code. You can analyze just them, so you don't have to look at the entire code base. You can do pull requests and incremental analysis. Only something which is built will be analyzed, not everything. So yeah, that makes it easier. And the analysis, well, it's kind of comparable to build time in some cases. In some cases, it's faster. Like we use precompiled headers, and our project is not really that large. So our check with the analyzer, it's not. It takes about the same amount of time as the build. I don't think it's too time consuming to run it, because on small projects it will be comparable time for analysis and the build. On large projects it will be kind of faster, because they usually take a crazy amount of time to build, basically because the compiler has to do everything, every header.
So when you do actually use this, the static code analysis, and it highlights a lot of issues. We were talking about that earlier. But when it does that, how do you figure out which ones are the most important from, I guess, both a development and a business perspective?
That's an interesting one, because if you get flooded with them, just get a lot of those, probably your best bet is to filter out any low priority stuff, because you get those levels of certainty in the log. So just look at high priority ones. I would say filter out anything which is not an indication of a potential critical error. Like we have optimization diagnostic rules, which just tell you, okay, you did this here, this one will be more efficient. I would filter those out too, because they're not critical. They're just give you hints about what a good practice might be. And I would say look at the messages from the perspective of how harmful they can be. Like if you see something like a dereference of a null pointer, it's harmful. If you see something about undefined behavior, it's harmful. If you see something about, oh, you've copy pasted 2 lines of code and they're similar here, I don't think it's really harmful. It may be, but chances are you can ignore it for some time. But usually, what we suggest to do, especially if you are dealing with a large project with a lot of legacy, you just check everything, you suppress everything, and you work with the new code. I'm not sure about that business perspective, because people who are in business perspective and people who do the development, they usually, they have different skill sets and they have different views on what's important and what's not.
That's true.
It's like a lot of times we had this argument with our CTO. It's like, dude, we need to do that, and that. It will increase our speed. It will make us more reliable. It will, I don't know, it will promise us the world of goodness and something like that from technical standpoint. And then he goes like, and how would we sell that? Like, would they know? It's now working like 30 minutes instead of 50 minutes. Do they know we have this super efficient system in place here, which is cool and modern and old templates and stuff like that? So yeah, it's kind of, they usually cool us down because because if we are given rule, I think we will rewrite everything and make it look obscure.
I understand. I have to fight that internally just with myself too, because I'm like, I learned this new thing. I want to go rewrite everything this way. And that's not always the best plan. So Yuri, we want to thank you for joining us and getting even deeper into what it takes to develop a static code analyzer. Guys, code analysis allows developers to keep their code base clean and detect problems before they occur. And this allows you as a developer to not worry about simple things and focus on higher level concerns like meeting your business requirements. The process to take away these concerns is anything but simple, however. Building and maintaining a static code analyzer takes a lot of work. Even if you aren't interested in building or working on one, understanding the process that goes into building such complex solutions can help you in your career. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to kind of hammer home the point about the value of having automatic checks. Today I had my day off, but I had my work laptop open and I'm watching our Microsoft Teams channel, mainly just so that I know what's going on when I go back tomorrow and I'm not clueless. And we had a bug that we did not anticipate because some requirements changed and we just didn't think about a particular use case, and our automated unit tests that run caught the fact that we did that. And having automated checks on your stuff is extremely valuable because you're not able to think at the level that you need to catch everything. And that's why you have tools like this, is so that you can catch things like dereferencing a null pointer, have the machine do it because that's what the machine does instead of having a person do it. Again, we had all these code reviews, all this stuff on the code, and we did not catch that problem until the machine caught it, thankfully by way of unit tests. So just want to hammer home how valuable that is. And that's pretty much all I've got.
Guys, you can hear more about Will's day off in the Aftercast, which you can get by joining us on Patreon. And we'll catch y'all next time.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.